So now we're rolling. And what we're going to cover today, analyzing customer requests. So customer being internal customer, usually materials, engineering, something like that. Here's our sourcing cycle, a world according to ISM. So we worked on recognition of need yesterday. Today we're going to work on specification of need. And then we'll go through the rest of these steps later on. So, analyze and advise on feasibility of internal customer requests. That's our task for today. Customer needs. The first two steps of the sourcing process are to recognize the customer needs and to develop the specifications for those needs, as opposed to customer wants. Supply management can use their knowledge of the market to help both steps. So a specification is used to communicate the requirements to suppliers. So the most simplest form of specification that we use is the drawing. And what we're telling the supplier is build the print, build it like this drawing says. And if they say you can't build it that way, then they submit a SRDC, which is a supplier requested drawing change, and engineering evaluates it, either does it or not. But that's a specification. Another specification we use would be a TRS, or technical specification requirement. And that's more for a system like a radiator that we don't design ourselves, but we have specifications that the radiator needs to meet. So Mala, go design the radiator to meet these specifications. That's what the TRS is. So conduct a needs analysis to determine the purchase characteristics that will meet the organization's business requirements. So distinguish between needs and wants. I mean, we look at wants later if we've met all the needs. And then supply management helps the customer understand the trade-offs between various requirements, such as cost and lead time, or cost and quality, etc. Technical considerations need to ensure that the customer functionality and performance needs are met while being as flexible as possible. So engineering at this company is responsible for ensuring that the customer functionality and performance needs are met, along with product management. Where we get a little stuck sometimes is being as flexible as possible. So important considerations include, should the organization make or buy the product? Usually this is the manufacturing engineering's domain. They will do a study, a make or buy study. What materials should be used? So this is design engineering, and purchasing kind of working with the supply base to recommend other materials. Design engineering has got some expensive stuff in there that they don't really need. Tolerances also affect what suppliers can use. If you got unnecessarily really tight tolerances on bends and stuff like that, you're not going to get very many suppliers to quote on it, but you can work with the supply base and the SRDC process or whatever to relieve some of those tolerances if they're not really needed. And then we have design for manufacturability and assembly, DFMA. So there's a couple of software programs. This is one. The guys that do this are specialists, usually manufacturing type engineers. And we've got 3 of them down in the Teardown Center, Benchmarking Center in Renton. But Kenworth also has a group that falls underneath the manufacturing engineering that has 3 or 4 engineers in there that will run software on these parts too. You send them the CAD model and they do a DFMA study on it. And they look at things like how to simplify the product by eliminating or integrating parts. So reduction in part count. If you make a bracket with 15 parts and a bracket with 3 parts, the one with 15 parts is going to cost a whole lot more. So how to improve the manufacturability of the parts. That's working with the supply base usually, and what's the easiest and cheapest way to manufacture the parts, and how to ease assembly. This is how do we help out our people on our factory floor to assemble these things? We've put little things in here that I guess you call it idiot proofing, but so you can only put it on one way kind of thing. That's designed for assembly. So very detailed part level analysis, systematic step-by-step design iteration, and cross-functional approach. And they use the software to do this. The DFMA lever, you're looking at each part, you're investigating the bill of materials, technical products, gathering, you're looking at mostly part count, types of materials you're using, and any design for manufacturing and design for assembly. Can the process be simplified? Can it be done at a lower cost? More complex parts may enjoy a cost advantage. Not usually. Part might be mass produced. So, here's the elimination of parts. You got all these parts, 11 parts. Whoops. Somewhere in here. You got 11 parts, and you bring it down to 3 just by combining the parts. Design for manufacturability. These have to do with tolerances here and materials. And then design for assembly. So self-aligning parts, self-fastening parts, that type of thing. That just helps them put the thing together on the factory floor. Logistics. So information and processes required to transport and store materials. So timing, how fast do you need the parts? Does the product involve special packaging? Is it fragile, like glass? Are there alternative products that don't require these special packages? What are the corporate goals, such as inventory turns? And will inventory material personnel be fighting the logistics personnel? So this is the classic problem with the goals and conflict of goals. So logistics, which is the guys scheduling the trucks, pull material forward and ship early to fill the trucks. Unfortunately, that means you get the material early and it decreases your inventory turns. But logistics is measured on, how expensive it is to run those trucks. If they can run them full, it's a lot less expensive. Materials, they want to push everything back until the day they need it. So they don't care if there's only one part on the truck. And don't show up until the day before I need it. That increases the inventory turns, which is what materials is usually measured on. So you got conflicting goals between these two groups, and you have to work that out. Organizational capacity, what and how much should the organization buy? Should we buy in larger volume to get a price break? Usually this doesn't affect PACCAR because we buy in such big volumes anyway. We don't do price breaks. If you're working in a smaller to medium-sized company, then you get very much involved in price breaks. If you buy 100, it's one price. If you buy 1,000, it's another price. Should the organization outsource some work or function to open more capacity? And this is where we use our MSSs. Do we want to bring that stuff in-house and make our plants bigger, or do we want to outsource that capacity to third-party logistics or MSS? And all questions on capacity should be viewed from a total cost of ownership, TCO standpoint. Available market. So supply management can use our knowledge of the supply market to advise the internal customers, engineering usually, on purchase requirements. Do suppliers have enough capacity? So engineering loves some of these suppliers that have really good engineering groups and are very responsive to our design engineers and help them out, and they're really good groups. Unfortunately, some of them, their operational side, where they actually make the parts and ship them to us, are terrible. And they have quality problems and they can't ship on time. So engineering wants to use them because they're easy for them to use, but purchasing's like, yeah, you can't use these guys because they're terrible with operations. So you could face supply chain disruptions with some of these guys, so you have to be careful. alignment with organizational policies, early involvement, ensure that requirements and sourcing decisions comply with functional as well as organizational policies. We have some policies in place about signing off on early supplier involvement, getting engineering on board to concur with the supplier choice. And we also have policies on how many suppliers that you need an RFX for. Usually it's 3. And the organization may have little known policies on social responsibility and supplier diversity. PECR does not have anything on supplier diversity or supplier social responsibility. When they look at those 2 things, diversity and social responsibility, PECR looks internal. Regulatory requirements. Decisions may be made when determining requirements for regulatory compliance. We run into this all the time with the EPA and the Department of Transportation. Also, you got to look out for things with, you don't want to be sourcing from North Korea or trying to. You could get it cheap, but it's not going to look good for you. All right. What steps are included in analyzing internal customer requests for procurement services when using the ISM 8-step sourcing cycle, which is this cycle right there? So go back to the question. So you're looking at the steps that are analyzing internal customer requests. Probably the first 2 steps. Any guesses here?
A.
Yeah, see, I think those are the first 2 steps. C it is. All right, we got one more here. Sean Doherty is a category manager for Acme. He's reviewing a request to purchase wheel and tire assemblies for use in production. So you're going to buy it as an assembly. The tire's already on the wheel. You'll have to mount the tires on the wheels before they bring them to the main production line. How should Sean approach this issue?
B.
Yeah, I think it's going to be B or C, and TCO is usually where they'll go with this kind of stuff. Let's see what they have to say. No. Yeah, B, to determine TCO. What's wrong with C? We'll only tell you what the wheel and tire combinations you have historically purchased. It will reveal nothing about where the outsourced assembly. Yeah, TCO would cover more than just the spend analysis on the wheel and the tire, which is what they mean when they say that. All right, there's 5 questions out there. You guys go ahead and jump on them, and we will get back together at 2:20 and go over the answers. Oh, they're on the chat. Yeah, you guys can just raise your hand when you get done. All right, I'm done. Let's go get some answers here. So the recall questions are the questions we do as a group. The practice questions are the ones you're doing individually. So number 1 is Bravo. Customer's process for budgeting and the expense takes place prior to the sourcing process. And number 2 is also Bravo. Because engineering needs help to complete the specification, procurement cannot do anything without a complete spec. The first step is the spec creation, would be a needs analysis. 3 is Charlie, because the DFMA study will determine optimum part counts and materials to use on the product. 4 is Alpha, because Ken needs to get an understanding of how much the seven-day lead time and special package requirements are going to cost. You can mandate them in the body of the RFP and then have discussions with the supply base and how much these requirements are. And 5 is Delta. Total cost of ownership approach should be used to value each of the scenarios that could happen with an estimation of the probability that each scenario would happen. Any questions? All right. Talk to you guys tomorrow. We'll do 1A3. Everybody have a good Valentine's Day.
Thank you.
Thanks, Rick. Thank you.
Thank you.